Welcome to The Explainer. Let's jump right in today because we are looking at an absolute game changer in the AI engineering space. Seriously, if you spent any time building AI agents, you already know the literal headache of wiring your models to external data and systems. It's rough. So today, we're doing a deep dive into the future of AI agent integrations, the Model Context Protocol, or MCP for short.
Just think about this for a second. What if your AI agent had a USB-C port? Before USB-C came along, connecting our devices was this massive nightmare of proprietary cables and mismatched ports. And honestly, right now, AI integration is stuck in that exact same messy, adapter-filled era. But what if we had a single, universal connection standard to let AI systems interact seamlessly with tools, data, and workflows?
Okay, let's dive into our roadmap for today's explainer. First, the evolution of tools, followed closely by the integration nightmare. Then, enter the Model Context Protocol. We'll do a REST versus MCP architecture showdown, show you how to actually build an MCP server, and wrap up with exactly when to choose which approach. Let's get to it. Section 1, the evolution of tools. Let's just establish our baseline real quick on how agents currently talk to the outside world. Right now, we rely on a very procedural, traditional function calling loop. It's kind of tedious. Say a user asks an agent for the weather. The LLM realizes it needs outside info. Step 1, select a tool from a hard-coded list. Step 2, construct a structured JSON payload with the right arguments, like the city name. Step 3, your application code takes that JSON and executes a traditional REST API call to some weather surface. And Step 4, take the result, feed it back to the model, and repeat this loop until the goal is met. I mean, it works, but you're manually mapping this stuff every single time.
Which brings us to Section 2, the integration nightmare. Because as your ecosystem grows, that procedural loop turns into a massive bottleneck. Think about the math on this. MCP was actually created to solve what we call the M times N integration problem. If you have M AI applications, say an internal agent, Claude Desktop, and Cursor, and N data sources, like Postgres, GitHub, and Slack, your integration cost scales exponentially. You end up building custom REST wrappers and API schemas for literally every single connection. To put it in the exact words of one of our sources, every app needs its own Slack connector, its own database bridge, its own file system adapter. If you're writing code, you feel this pain. You're probably writing the exact same integration code twice or 3 times with slightly different schemas for every new app you deploy. It is totally unsustainable. Section 3, enter Model Context Protocol. Bring the energy up because this is where the paradigm shift actually happens. This is an open standard introduced by Anthropic in late 2024, and it's now stewarded by the Agentic AI Foundation. And this perfectly illustrates that USB-C analogy we talked about earlier. MCP acts exactly like a universal port for your AI applications. It's a single, standardized protocol that gives us a common interface, so instead of writing custom APIs for every single tool, you write an MCP server just once, and boom, any AI application that speaks MCP can plug right into it. It completely flips the underlying math. This centralized MCP protocol layer sits right in the middle, and it collapses that M times N nightmare into a super simple M plus N. You write the tool once as an MCP server. Then, any MCP-compatible host, whether that's Claude Code, LibreChat, or your own custom agent, can instantly discover it and use it. Let's break down how this builds into an actual architecture. NCP defines 3 specific roles. First up, the host. That's the application driving the conversation, like Claude Desktop or your IDE. Inside the host is the client, which is just a library managing the connection. And finally, the server. The server is a completely separate process exposing the tools, like a local file system or a remote database. And they all communicate seamlessly using a structured JSON RPC standard. Section 4, REST versus MCP architecture. So how does this shiny new standard actually stack up against the traditional way we've been doing things? Let's do a direct head-to-head. Now, what's incredibly interesting here is the discovery phase. With a traditional REST API tool, discovery is completely manual. You, the developer, have to configure every single endpoint, define the schema, and map it for the agent. It's super high maintenance. But with an MCP tool, discovery is automatic. When the agent connects, the server dynamically exposes its tools right then and there via a tools/lister request. Plus, while REST relies on stateless HTTP, MCP uses streamable HTTP or standard input/output. That gives you rich, stateful, bidirectional communication.
I do want to clear up a massive point of confusion here, though. MCP and function calling are not competing with each other. They aren't alternatives. Function calling is a model-level capability. The LLM brain, like GPT-4 or Claude, is still emitting a structured JSON object to request a tool. What MCP changes is the protocol level. It dictates how that tool execution layer is packaged, discovered, and connected. So the model still calls the function. MCP just provides the universal wiring to make the whole thing happen.
Section 5. Building your MCP server. Okay, so how hard is it to actually build one of these? Let's put on our developer hats and look at the implementation.
It is remarkably straightforward if you use Python and the official SDK. You use this FastMCP class, and it handles all of that complex JSON RPC protocol plumbing for you behind the scenes. Here's the absolute magic of it. You just write a standard Python function, and its doc string literally becomes the tool description that the LLM reads to decide when to invoke it. No joke. And if your function returns a dictionary, the SDK automatically serializes it to adjacent text block for the model. It's a wildly elegant developer experience.
Section 6. When to choose which. Look, as amazing as MCP is, we need a quick reality check. As an engineer or an architect, when do you actually deploy this architecture versus standard REST? MCP's value really compounds with ecosystem size. You absolutely want to use it if you're building for developer tooling ecosystems, like if you want your tool to be instantly accessible inside Cursor or Claude Desktop without writing bespoke plugins. MCP is your answer. It's also perfect for plugin marketplace patterns, or those really complex multi-system agentic workflows where an agent needs to query a database, read Jira tickets, and hit internal APIs all in one single task.
But the crucial takeaway is this. MCP is overkill if you're just building a single-purpose internal agent. Seriously, if you have one little agent that just classifies emails for one specific inbox, putting an MCP process boundary in there just adds unnecessary complexity. For that use case, sticking to standard REST function calling with direct API calls is going to be faster, simpler, and way easier to debug.
Real quick, before we wrap up, what about prompt injection? We absolutely have to talk about the biggest security blind spot when adopting this new standard.
Because MCP makes it incredibly easy to plug into third-party community-built servers, you are inherently opening up a brand new attack surface. When an MCP server returns a tool result, that result goes directly into your model's context window. So a compromised server could return a payload that looks exactly like legitimate system instructions, potentially hijacking your agent to, say, forward all your future messages to a malicious URL. Always evaluate trust before connecting a third-party server to a privileged system.
Which leaves us with this final provocative thought. As the Model Context Protocol ecosystem continues to explode, with native support already rolling out across Anthropic, OpenAI, and Google, will writing custom REST API integrations for AI soon feel as outdated as burning CDs? Think about it. The era of bespoke AI wrappers is ending, and the era of universal, plug-and-play AI intelligence is officially here. Thank you so much for joining me on this explainer, and I hope you're as pumped as I am to go build your first MCP server.